Hey guys, it's Miss Buck. So what I'm going to do is just sort of walk you through the task, and hopefully it will answer a few questions for you. One thing that I can't, well, it doesn't work very well, is if there is a video embedded in the Nearpod or the Google Slide presentation. If I click on the video, it works, but it sounds really weird. It looks really weird. So I'm just counting on you. If there's a video clip, we need you to watch the video clip. It's there for a reason. So I'm going to just pretend here I am. I'm a kid and I'm sitting down at my computer. Remember, my canvas is going to look a little bit different than yours. So I'm logging in. There's our schnoodles. All right, so here it is. Now, it hasn't been published yet, but it will be for you guys. All right, so it's right here, okay? So it says task 1, due date, Wednesday, April 1st by 9 p.m. I put a time in there because I figured some of you would ask, all right? So here's task 1, and I'm going to click on it. When you click on it, these are all what are called pages in Canvas, and it's exactly what it sounds like. It's just a page that I can put lots of different things on that page for you to do. So I started out, I gave you the standard we're working on. It's a pretty big standard. It says you guys have to analyze and interpret data. So you know what that means. You're going to be looking eventually mainly at the fossil record is what you're going to be analyzing. We're looking for patterns, all right? There's our cross-cutting concept of patterns in the fossil record. And all right, what is it we want to figure out from looking at that fossil record? Well, we need to be able to figure out what different types of things existed, how much diversity, that just means all the different things, and when we start to see those things in the fossil record. So when do we first see single-celled organisms? When do we start to see fossils of fish? When do we start to see fossils of plants? We can use the fossil record to tell us when things went extinct. We have a very clear idea because we can analyze the fossil record of when, for example, the dinosaurs went extinct. But we've actually had several mass extinctions, and so we'll be talking about that. And then change in life forms. And so that change in life forms is referring to the idea of following one organism, a population of organisms, not one, but a population of organisms, and then looking at how their fossils record how they've had changes in that life form, in that population over millions and millions of years. And so we'll get into that. So this is obviously a big standard, right? This isn't something we're going to do in one lesson. We're going to first learn a little bit about the fossil record and just how we analyze it, and then we'll kind of start breaking down each of these, all right? All right, so step 1 that we do every year with kids is we have to understand the fossil record. And to understand that, you have to understand this idea of what we call geologic time. So scientists think our Earth is very, very old. It is so old and has so much geologic history that you have to organize it some way, guys, just in order to be able to talk about all the different things that happen. And so that's what this lesson is about. This lesson is about how did we organize all of that geologic history. So it says we're going to be using a Nearpod to complete the following note sheet. The note sheet is a Google document, and a copy will automatically be made and placed into your Google Drive when you open the document. After you complete the notes, please submit the notes to me through Canvas. All right, so right here's the link. Okay, so I'm going to open that up. Now remember, mine will look a little different, but you will know that it's made a copy when you see right here, you see a little blue link right there. That blue link, it's saying, hey, I made a copy for you and I just put it in your Google Drive. So you could click right there and it would open up and there's your Google Drive. You don't have to try to type in here, all right? But you need to get that opened up. All right, that's opened up. I'm pretty happy with that. Okay, so that's good. I see that. All right, so I made that little copy. And now remember that I'm back here on my task one. Okay, again, mine works a little bit different. So you want to get your note sheet all opened up and have it opened up in a tab for you. And then I have a Nearpod for you. So here's the Nearpod code. And look, if you have forgotten, you can go right over there. Okay, you can go right there. And there's the Nearpod code. I don't even know if it's going to do this for me. It'll probably, since I'm the person that made the Nearpod, it may look different, but I'll just copy that. I'm going to click Nearpod. And so mine looks different. I'm the person that made the Nearpod. Okay, so yours, you'll put the code in. And we'll just go ahead, let's see, we'll go right here. I guess I'll do a live lesson to have my screen be kind of full size. Let's see what happens. We'll get rid of that. All right, so the very first thing that you're going to see on your screen, remember yours will look a little bit different, is a little matching game. And don't worry about it. We want you to just try it a couple of times, see how you do. You're going to see a bunch of different pictures. There's some pictures of an early human. I think there's a plant there, some reptiles, single-celled organisms, and then there's some dates, some years, like it'll say things like 300 million years ago or 4 billion years ago. What you're trying to do is match up when you think those different living things appeared, that we first have fossil record appearance of them. So just go ahead and try that a couple of times. Now remember, mine looks different because I would see how you were doing in class right here. So do that. Okay. And then we've tried to make the Nearpod so it really tells you and walks you through what we want you to get out of things. So this slide says, here comes a video clip. Watch the video on the next slide to get an overview of the geologic time scale. Just like it's hard to really imagine how big the universe is, it's really hard for people to imagine just how old the universe is. And so you'll click here and you'll watch this video. And again, if I click it, it just sounds and looks really kind of garbled. So we are counting on you, absolutely counting on you to make sure that you are going through the Nearpod. It's self-paced. You remember that because it's self-paced, you can watch the video more than once. You could watch it 2 or 3 times if you need to, all right? And then we have a website that we love for kids to take time and explore. And the reason that we like it so much is this website pulls together a whole lot of different things. It not only goes all the way back to the formation of the universe and shows you some of those things we talked about with the Big Bang Theory, it also kind of shows you some things about Pangea. It shows you different things about the Earth's atmosphere, when the Earth formed, different things. So, and I'll show you how it works. But here are the things we want you to look for. We want you to look for, remember we said that the first elements that formed, we would have had hydrogen, and then we know hydrogen would fuse together to begin to form some of our helium. We talked about the fact that the elements up through iron are formed through that ongoing process of nuclear fusion inside a star. And that's what's going on inside our star, which is the sun right now. Remember that we have the formation of the universe, but it's billions of years before the Earth comes along. So we have a big lag of time before our sun and then our solar system is formed. But once we do get the Earth, you'll notice again on this website that they kind of are trying to show the continents in motion, and they're even showing you how the oxygen content in the air was changing. So here's what it looks like. You will probably get something that looks like this when you click, all right? And that's okay. You just click on there and it will let your Flash player come up. And do you see over here, there's this little bitty red thing? That little red thing is your slider, okay? And so you can click on that and it's a timeline. So here's our Big Bang, which was the mother of all expansions. And I love they use the word expansion instead of explosion. Immediately as I move the slider, you start to see hydrogen and helium. That's our first elements. It is a super, super interesting website. There's the first stars shining. I'm just moving this slider. We start now because we have our stars. We start to see more and more of the heavier elements are forming. Remember, and notice down here though, they only have it forming up to iron, okay, which is correct. There's a lot of interesting reading up through here, but you can kind of click and go, and I'll just sort of show you. Remember that as stars move through their life cycle, eventually when some of them go supernova, we start to get elements heavier than iron. And there they come. All right, we don't have our sun yet. Let's see how far I have to go to get the sun. Going and going and going. So I'm moving the slider. Aha, there we go. There's our sun right there. And I'll keep moving it. And I think there's our molten Earth forming. And it says Earth's atmosphere initially lacks oxygen. So not very good for life yet, right? Without any oxygen. So we'll keep going. We get our solar system. We think that our moon formed from a collision. We think some large object kind of slammed in and into our molten, melty kind of Earth and took a chunk of that outer layer off. The Apollo astronauts, when they went to the moon, collected moon rocks that provide evidence to agree with that. Those moon rocks are made of the same material as our lithosphere is, so that seems to agree. And I'm just going to go a little bit more with this. Yes, those are meteors, just constantly coming down and slamming into the Earth. And over here, you notice they start to show you how much oxygen is in the atmosphere. Well, not a lot, all right? And look, something has popped up. So up here at the top, we have some chemicals that have popped up. And you know from last year that we have elements and compounds and mixtures, and you know that a compound is two or more different atoms that are chemically bound together. So we start to see that we have there's some elements, and we start to see that we have some important compounds popping up. This one's really important. And here is a little single cell bacteria. And I'll go just a little bit more. And here's what I want to show you. Every once in a while on this site, they'll put a little video clip in there for you, okay? And so you see there's the little triangle. And so you can actually click on that and watch a little video clip. And there is photosynthesis starting, which is really important. And again, we don't expect you to read every bit of this, but we love the website and we would sure like it if you guys would spend some time. Now, what I want to show you really quickly is you notice when it gets to the end, it goes down here, and then you'll continue to move. All right, so you've got some bacteria up there, and I bet you're going to start to see some movement of these continents right here as we're kind of moving through. All right, so, but I'm going to stop. So I'm going to let you do the rest of that on your own. All right, it says now it's time to take some notes. So that means you'll go back and forth between your Google note sheet and your Nearpod, all right? And just reminding you, if you didn't already open them up, this is what you want to do. Click on your blue copy and take notes. And then here's your notes, all right? So most scientists agree the Earth is over 4.5 billion years old, and that we call it deep time. And that's just super hard for people to understand. So because it's so much time, we took it and we organized it into something called the geologic time scale. So then scientists can talk about important events that happened, okay? You might remember that I have this poster on my wall in the classroom. I love this poster. And because over here we have our layers of sedimentary rock, and we have our little fossils in here. And then over here on the right-hand side, they are showing you the names of these time periods of the geologic time scale. We don't expect or ask kids to memorize all those. We're not interested in that. We are interested in your being able to look at something like this and analyze it, see what information you get. There might be more to this picture than you realize. For example, it has the Earth forms 4.6 billion years ago, but you notice right here, and I think the oldest rock layers we have now, I think, are around 4.3 billion years. But you notice right here, we don't have any fossil evidence. Okay, so there's no fossil evidence right here. So that tells us something. It tells us that the Earth formed, but the Earth was not, the environment of the Earth wasn't ready to support life of any kind as we know it. Actually, because this says 2.5 billion years ago, so actually for very long time. And when we do start to see our first little bitty fossil, it's right there. And I noticed that that is pretty simple looking. And then I noticed right here, just something kind of really big seems to happen because I have no fossil evidence, little teeny fossil evidence, and then boom. Well, right over here, I noticed that the name of that little time period right there is called the Cambrian. I say Cambrian, I guess you could say Cambrian, but I say Cambrian. And we have an important thing that happens here. It's called the Cambrian explosion. Now, it's not an actual explosion. What it means is that we notice that the fossil record all of a sudden seems to show us a whole lot more complex evidence of fossil evidence of living things at that point. So we go from this, and then all of a sudden we go here. So you notice in the picture, we have three main, these are called our eras. So this is our Paleozoic, and then we have our Mesozoic and our Cenozoic. And then each of those are divided into some smaller sections, and these are called periods, okay? And we have some questions for you to answer on your note sheet. Again, by looking at this, I'll point out some things for you. For example, from the Paleozoic to the Mesozoic right here, I notice over here it says gigantic extinction. That's interesting right there. Don't have much information about it yet, but something happened there. And I noticed right here when I went from the Mesozoic to the Cenozoic, oh, look, another big mass extinction of some sort. So I helped you with this question. Use the picture to figure out what happened to divide the time into these three eras. So guys, you notice that these time periods, they're not equal. We don't divide our geologic time scale into these nice equal sections. What we do is we have divided it based on some type of important event that happened. So again, we have a video here. It's just a video clip, and this is from the Big Think people. We like it a lot, and he will kind of go over again some of those geologic time periods so that you're starting to kind of get familiar with them. And then again, you can see that we kind of are expecting you guys to be pretty independent with this. What we want you to see on this next one is another example of a timeline, but this time the timeline's kind of just going left to right. And the big pattern that I want you to see from this is how living things, our fossil evidence shows us that we started with these single-celled organisms, one cell big, and then as time goes on, the living things slowly get more and more complex. So I'll show you the easiest way. Again, I'm not going to go all the way through this, but if you click Get Started, oh, look, it says we blocked a risky connection. Well, that's good. All right. So what I do is I start right here on this circle, and it says the formation of the moon. Okay. There's a little bit of information that you can read. And what I do, and if that's too big, all I'm doing is using the my little scroll bar on my mouse, and I'm just backing that up a little bit. Okay. So it's kind of giving me an idea of what happened first. And then right here it says next. This is the easiest way, I think, to move through this. I'm going to hit next, and it will just kind of go to the next thing, big event, and it says emergence of life on Earth. And again, these are stromatolites. And I want to go see these. I can't remember. I think they were in Australia, but now I'm not sure. I got to go look and see. But they're like big clumps of single cell bacteria is what they are. But I've read that these were super important because these actually started pumping out a bunch of oxygen into our atmosphere. I've got to find out where these are. They're interesting. But again, easiest way is just click next. Now we have multicellular life starting to come along. Okay, so I'm not going to click all the way through. I just want to make sure that you're comfortable. And again, what we want you to do is click through and at least look at each of the pictures, at least read this little bit of information. That's not very much. Okay, you can do it. But again, the idea that things are getting more complex. And here we have arrived at that Cambrian explosion. And we start to see a lot of evidence of more complex organisms there. So I'm going to get out of this. Okay. So spend some time there. And then we're trying to tell you, hey, go back to your note sheet. So the very first big chunk of time we call pre-Cambrian. Pre means before. And it actually makes up 80% of the history of the Earth. Nobody was there, okay? We use evidence from rocks and the lack of fossils to give us some idea of what the Earth was like. And we think it was probably covered with a lot of volcanoes, impact craters from all those meteors. We are really condensing a whole lot of time, millions of years here. Oceans formed by the end of the period. We start to see our landmass. And then finally, some simple bacteria begin to produce oxygen. Okay. So this is an artist's idea of maybe what that would have looked like. Obviously, nobody was there. And then we have the Cambrian explosion. And that's where we start to see in the fossil record all these really cool, complex animals. And we see major what we call body plans represented. We start to see body plans that are symmetrical, for example. And we love this little video clip. You'll get to see Bill Nye in here. This is a short video clip, and it absolutely has some of the coolest fossils. And then they animate the fossils for you so you can kind of see what some of these things would have looked like. After we had that big Cambrian explosion, our next important era is this Paleozoic era. So this is the age of the invertebrates. And in case you've forgotten, an invertebrate is an organism that does not have a backbone. So think bugs. And we also know that during this time period, there was actually more oxygen in our atmosphere than there is today. And because of that, scientists tell us that that lot of oxygen, that big amount of oxygen, probably led to the development of our insects being much bigger than they are today. We think, although I think there's starting to be a little bit of controversy on this next thing, that most life at this stage was only in the ocean. So the fossil record shows us our first fish. And then we see the fossil record shows us amphibians. And then remember, we had a big mass extinction at the end of this era. Now we have to actually talk about the main mass extinctions that we've had, and we'll do that in another lesson. We'll talk about some different theories of what happened to cause each of those extinctions. They're pretty cool. Most kids are familiar with the dinosaurs, but we've had other mass extinctions other than that. So you notice now we have more complex living things. The next era is the Mesozoic. The Earth's climate is warm. We have plants that are abundant. This is where you would have had what we call the age of the reptiles. This is your dinosaurs. Again, you have the mass extinction of the dinosaurs at the end of this particular period. And then we get to the Cenozoic. And so the Cenozoic is finally, you're going to see the age of the mammals. And again, most scientists feel like because the dinosaurs went extinct, that actually opened up what we call a niche, an ecological niche for mammals to begin to flourish and the population of mammals to grow. And towards the very end of this, we would have modern humans. Humans are very new on the scene. I mean, if you really think about the whole geologic history of the Earth and you want to put humans in there, we actually haven't been here that very long as a species. So it's kind of something interesting to think about. So then, again, at the last slide, you go all the way back to where we started, and we're going to ask you again and see if you can do it faster this time, if you can match everything up. And we've even asked you to add this information into your note sheet. All right, so that's kind of the Nearpod. All right, so here I am. And so you will have to, again, the expectation, guys, is that you will go through that Nearpod on your own. Okay, you've got your notes. You're going to fill those in. You're going to watch the little video clips and things as you go through. And we have tried very hard to build some accountability in by asking you some questions about the little video clips and different things. And then don't forget, okay, so here's the video to help guide you through it. And then we added a little bit of extra things. If you're interested in this topic and you like it, you can explore this. Okay, you can click here. And then finally, just a reminder to submit your completed note sheet to me. So remember, when you are ready, you will go back into Canvas. Okay. Yours will look like this, except it will have a big submit button, okay? Mine doesn't because I'm the teacher, but you'll have a big submit button right there and you'll submit it in. And remember, you can always double check with me. You can shoot me an email and say, hey, did it come through? Or however you want to check with me, and that's fine. And you'll be hearing from me if I don't get it submitted. Trust me, you'll be hearing from me, okay? So I hope this helps. I'm going to do this type of video for every single lesson just to make sure you know where to find everything. And hopefully I'll see some of you on our Zoom meeting. Okay, guys, let's see. I'm supposed to go up here, and then I will stop.